Hi everyone. In topics we already discussed about the reflection and the deviation when a ray of light incident on any surface. If this is the reflected surface, if this is the angle of incident, if angle of incident is I, so if the ray reflected here, the deviation we can give by phi minus 2I. Okay. Similarly, if this is the reflecting surface, if this is the normal, if they give this angle as 30 degree, so what will be the deviation? Deviation we already know 180 degree minus 2I, but this 30 is not a I, so I is going to be what? 60 degree. So delta is 180 minus 2 into 60 degree. So delta equals to 180 minus, so this is 120, so delta equals to it's just 60 degree. Okay. So similarly, if this mirror is only making some angle with the horizontal, if this is the mirror, if it is making some angles, they again 30 degree here. If a ray of light incident at this point, so normal is going to be here now. So if they ask what will be the deviation, what you can calculate here. If this is 30 degree and this is also going to be 30 degree. If this is 30, again your angle of incident I is equals to 60 degree. So again your deviation is 180 minus 2 into 60 degree, same as before. So delta is going to be again 60 degree. Okay. So if here they change the angle of incidences. If suppose instead of this, if we rotate the mirror only, suppose you are having mirror here. If suppose this is the mirror, so normal drawn is here. If angle of incident is R, so reflected ray is going to be here. Okay. So if now if I move or if I rotate the mirror by an angle theta, if mirror is rotated by an angle theta, so what they will ask, how much reflected ray will move or how much reflected ray will rotate. Okay. So if this is theta, then normally will shift here. Normal is going to be at this point. So what is this angle? This is going to be theta. Now this is not a reflected ray. Reflected ray is going to be here. This is what your reflected ray. So how much it is shifted or how much it is rotated? This is what delta. How much it is deviated from initial reflected ray. So how we can find this delta? Suppose this is the normal. This total is I plus theta. Then here this is also angle of reflection for this normal. Okay, this is what before normal. This is I plus theta is the new incident angle. So reflected angle is also what? I plus theta. So total from here to here. So total angle is what? 2 into I plus theta equals to. From here to here, how much it is? From here to here. It is going to be from here to here, it is I. Again, here it is I. So I will write 2I plus. This is what? Delta. So 2I will get cancelled. So deviation is going to be 2 theta. So if mirror is rotated by an angle theta, the reflected ray will rotate by an angle 2 theta. If mirror is rotated 30 degree, your reflected ray will move by 60 degree. That is what the meaning of this delta equals to 2 theta. Okay. So or suppose if this is a normal, so if the angle of incidence is R, suppose a ray move towards the normal. So what will happen to your reflected ray? Reflected ray will also move towards the normal. But direction is what? Direction is anti-clockwise. So if incident ray move by an angle theta, so reflected ray will also move an angle theta, but in opposite direction. Okay. So this is what the simple questions based on the reflections. We will see next. So second law, I equals to R, angle of incidence equals to angle of reflection. We can also use it in finding the point of incident for a sphere. If suppose your mirror is a sphere, so it means it is silvered from inside. So in this case, if they give the radius, so radius of this sphere is says r. If a ray of light incident here, so obviously it will reflect on this one. If they ask this coordinate x comma y, okay, so how we can calculate x comma y here? So just to resolve this into x and y axis, okay, so what will happen? To take a normal over here, if angle of incidence is theta, okay, if this is theta, this is also going to be theta, this is a radius, so this is also going to be a radius, okay. So if this is the radius, so how we can calculate the x comma y here? Now you want to find this x and y. This is what your x and this is what going to be y, okay. So now take cos theta equals to, from this triangle, cos theta equals to x divided by r, so x by r, so x equals to r cos theta. Similarly for y, so take sin theta equals to y divided by r, so y by r, so y equals to r sin theta. Now we want coordinates x comma y, so x comma y is equals to minus r cos theta, because it is there on negative x axis, so minus r cos theta and plus r sin theta. This is what your x comma y you can calculate. Suppose if they give the angle, say some 30 degree, suppose this is your sphere, say radius is 2 centimeter. If the angle of incidence here, you can take it as some 30 degree, okay. This is what. So what is this? Angle of incidence is 30 degree. If here it is 30 degree, here also it is what? 30 degree. Now, so you want to find x comma y. So x comma y is minus r cos theta and plus r sin theta. So x comma y equals to minus r is 2 cos theta, means cos 30. Cos 30 is how much? Cos 30 is root 3 by 2. So r 2 sin 30. Sin 30 is what? 1 by 2. So what you will get? This is what? Minus root 3 comma 1. So this is what your x comma y. Okay. So instead of the sphere, if they give some other curves, suppose if they give the spherical your surface as some curve like this. Suppose if this is the, say, x equals to y square is the curve. So this is what going to be incident here, and it will reflect. Say angle of incident, you can take it as theta. Okay. So now here how we can calculate the coordinates x comma y. We want to calculate x comma y. So how we can calculate? Now draw tangent here. So if you draw the tangent here, if this is theta, this is going to be what? 90 minus theta, because this is the normal. If this is 90 minus theta, this is also what? 90 minus theta. Okay. So if you know this angle made by the tangent with the x-axis, you can write slope as, slope is equals to, what you can write? You can write tan theta. Theta is what? Tan 90 minus theta. Okay. So similarly, you know, slope is also equals to dy by dx. So differentiate this curve, x equals to y square. So this will become dx equals to 2y dy. So dy by dx is equals to 1 by 2y. But this is what? This is slope. Slope you already know, tan 90 minus theta, and theta you already know, that is given. So what you can write? Tan 90 minus theta is equals to 1 divided by 2y. So from here you can get value of y, then you substitute again that y value in x. So you can easily get x comma y. Suppose if you take a curve here, suppose this is what the curve. If the angle of incident here, you can take uh, say some 30 degree. Angle of incident you can take 45 degree. Okay. So if this is 45 degree, so draw the tangent. Okay, you can draw the tangent over here. Okay. So what you can write? So your slope is if this is 45, this is also 45, so here also it is going to be 45. So tan 45 is going to be your slope. So slope is equals to what? 1. So dy by dx. What is dy by dx? Dy by dx is nothing but 1 by 2i. So 1 by 2i is equals to what? 1. So y equals to 1 by 2. If y is 1 by 2, x is 1 by 4. So x comma y is going to be 1 by 4 comma 1 by 2. So this is how we can take use of this method to calculate the point of incident x comma y. Okay. We'll take one more example of curved surface. If I change the angles, if this is going to be your x equals to y square, and here angle of incident you can take it as say 30 degree. Okay. So here angle of incident is 30 degree. Now we want to calculate x comma y. Okay. So now draw the tangent here. Okay. If this is 30 degree, this is going to be 60. If this is 60, this is also 60 degree. So slope is equals to tan 60. So tan 60 is how much? Tan 60 is root 3. Okay. So if tan 60 is root 3, again we know that if you differentiate this one, what it will happen? Dx equals to 2y dy. So dy by dx equals to 1 divided by 2y. This is nothing but slope. So slope already we have found it is root 3. So what we can write? 1 by 2y equals to root 3. So y equals to 1 divided by 2 root 3. Y equals to 1 divided by 2 root 3. So x equals to y the square. So 1 by 2 root 3 the square. So this will become 4 3 12, 1 by 12. So x comma y is equals to 1 by 12 comma 1 by 12 1 by 2 root 3. This is what going to be your answer, x comma y. Okay. So we will discuss few things on the plane mirror. It is very important. So later again we will go with the curved surfaces. But before that, what is a plane mirror? What is the plane mirror? Okay. So plane mirror is nothing but a perpendicular bisector between the image and object. So if this is your object, so if this is your image, so your plane mirror is nothing but a perpendicular bisector. Perpendicular bisector between line joining object and image. Okay. So here, if a mirror is at this place, okay. So if this is a horizontal line, if object is going to be here, say at point A, or you can take O only as an object. So a ray of light will come here, then it will reflect. If you extend this line, so what you will get? You will get the arc. That is what the image. Okay. If suppose this is going to be angle theta, what is this angle? This is also going to be angle theta, and this is 90 degree, and this is also 90 degree. Okay. So if two angles are same, then third angle is also going to be what? Third angle is also going to be same. So this is what you can take theta dash. Okay. So now these two triangles are what? These two triangles are congruent. So you can write it as their sides are also equal. So I can take if you take this as some point A. So O you will take as pole P. So OP equals to OI. That is what? Very important characteristics of plane mirror is the object distance is equals to image distance. Object distance is equal to image distance. Okay. So suppose you are having a mirror. Now I will take this as x and y axis. So if mirror is here, if suppose object is at a point say 2, 0, they'll ask where will be the image, what is the coordinates of image. Okay, so how we can calculate here? Just you have to extend this line. So what we will get? What is this distance? 2. If this distance is 2, this is also going to be what? 2 only. So what is your image coordinate? Image is going to be here. So you will get it as 0, 2. Okay. So that is what I of x, y is 0, 2. If they ask what is the distance between image and object, if they ask distance between image and object, so how we can calculate? Simple. If this is 2 and this is 2, obviously right angle is there. So what you can get it? You can get simply this distance is equals to root of 2 the square. So you will get 2 root 2. Okay. So this is what distance between image and object. They may ask what is the distance of object from the mirror. They may ask what is the distance of image from the mirrors. Okay. If they ask what is the distance of mirror object from the mirror, so if this is the theta angle, so what you can write? You can write if this is going to be 90 degree, so sine theta equals to this distance. If you take it as say d, so d divided by this is what 2, so 2, so d equals to 2 sine theta. They will give that angle. Okay, so this is how we can calculate the coordinates of the image as well as distance between object and image, or if they ask distance between object and mirror or image and mirror. Similarly, instead of this one, if they put some other angle instead of 45, if they put some other angle, say suppose if the mirror is kept like this, okay, say it is making some angle 30 degree. Now your image is not going to be on the y-axis. Okay, so where image is going to be? Image is going to be here somewhere. If this is 2, 0, image is going to be here. Okay, so this is what x, y you have to calculate. So how you can calculate x, y here? But you cannot use the same technique here because it is not going to be on the y-axis. But if this is 2, this is also going to be 2. So take only this vector here. So if this is the 2, so if this is making an angle 30, this is also making an angle 30. So total angle is what? 60. So this is what? Angle 60. So you can write its components now. What you can write? What is x? X is 2 cos 60. What is y? Y is 2 sin 60. So you can easily get it. So x equals to 2 cos 60. Cos 60 is 1 by 2. Y equals to 2. Sin 60 is root 3 by 2. So your x comma y is going to be 1 comma root 3. Okay. This is how you can calculate the x comma y here. Again, you may calculate what is the distance between object and image also. Okay. So sometimes what will happen? Sometimes object is not in front of mirror somewhere. Suppose if object is here, if this is the object and mirror is going to capture at this point. Okay. So where will be the image? Whether image will form or not. One thing is image will always form. Image will form. But this person, a person standing here, he will not see his image. So where image is going to be formed? Image is going to be formed somewhere here. It will reflect, other way will go, so that will reflect. So where image is going to be here? Image is going to be at this point. Okay. So how we can calculate this distance? Again, you can extend this mirror. Okay, because we already know plane mirror is the perpendicular bisector of the line joining O and I. So now this is what we call it as field of view. You already know that one. So now we can calculate the distances here. For example, I will take the same example here. Suppose Suppose mirror is kept here only, say at an angle 45 degree or theta. Instead of taking object here, if object is here, what is the coordinates of object? 0, comma, minus 2. So what will be the coordinates of image here? Coordinates of image is, you can just extend this line. So where you will get, this is what your I. So what will be the I? I is nothing but, so minus 2 comma 0. So x comma y is equals to minus 2 comma 0. Okay. So this is how you can calculate the coordinates of image. Or else, if suppose if they give the length of image, suppose this is what this is going to be mirror. Okay. Suppose object is here. Object is at a point. AB is the object. Okay. So A is at 0 comma minus 1, B is at 0 comma minus 2. Now there will be the image. Image is going to be here. So this is what its image A dash. This is what going to be its image B dash. So what is this coordinate? This coordinate is nothing but minus 1 comma 0, and this is minus 2 comma 0. Okay. This is how you can calculate. Remember, these things will come on the axis if and only if angle is 45. If and only if angle is 45. Otherwise it won't come on the axis. At that case we have to go with this technique. Okay. About the plane mirror. So what will be the conditions? Condition to see full image. Full image. Suppose you are 160 centimeter height. Then what will be the length of mirror to see your full image, or at what distance you have to stand? If you are having a small mirror, if you stand in front, you may not see your full image. If you go away from the mirror, you may see your full image. If you keep on going away from the mirror, you think that you will see your full image, but you will never see your full image, because conditions are different. If you want to see your full image, the height of mirror or the length of mirror will act the major role. That is what? Suppose you are having a mirror here. I will take the full mirror. We don't know how much part of it is useful. Suppose a person is standing at this point. A person is standing at this point whose height is, you can take it as h. Okay. So if this person want to see his full image, he want to see his feet also. So a ray of light will come and it will reflect. Okay. So he want to see his head also, so a ray of light will go and it will reflect. So where his image will form? His image will form somewhere here. Okay. This is what his image. Okay. So now, if this distance is, you can take it as 2 meter. So image is also going to be at 2 meter. Now we have to calculate this length of the mirror. This is what you can take it is y, and this x is what? Above the ground. At what height you have to fix your mirror. So these two x and y can calculate with the help of similar triangle concept. Suppose you are having two triangles of sides A, B, C and D, E, F. If triangles are similar, triangles will become similar when their respective angles are same. Okay. So if triangles are similar, what will happen? The ratio of sides are going to be equal. Ratio of their sides are going to be equal. Okay. Or you can write it as A by D equals to B by E also. This divided by this equals to this one divided by this one, or this by this equals to this divided by this one. Okay. So we can use that technique over here. So suppose you consider this triangle and this total triangle. Okay. This angle is same for both, and this is 90, this is also 90. If two angles are same, means third angle is also going to be same. Now these two triangles, this small triangle and this bigger one, are going to be what? Are going to be similar triangles. From these similar triangles, what I can write? I can write x by 2 is equals to h divided by 4. The total length you have to take. H divided by 4. So x equals to h by 2. X equals to h divided by 2. Similarly here, if this is 2, this is also 2. If this is 2, this is also 2. So what will happen from this triangle, and from this total triangle, okay? If this is h, this is also going to be h. So ratio of sides y by 2 is equals to h by 4, h divided by 4. So y equals to h by 2. That means the length of mirror should be half of his height. Length of mirror should be equals to half of object height, that is h by 2. Then where to fix it? We have to fix it above the ground level at a height equals to again h by 2. So height of mirror where you have to fix is also equals to what? H by 2. This is what the conditions to get the full image. So with the help of this one, you can easily calculate the length of mirror to find the full image of any person. Suppose average height of your family members is say 180 centimeter. Then how much mirror you have to purchase? You have to purchase just 80 centimeter, or where you have to fix? You have to fix at 80 centimeter above the ground level, like that. So suppose you are having a mirror. Suppose full mirror is there. In front of that at 1 meter, a person is standing. Whose height is say, going to be 2 meter. Okay. But what is there? Eyes are not going to be at top. They will give eyes are 20 centimeter below. Eyes are 20 centimeter below. From here to here, how much it is? Now 180 centimeter. To see his full image, what should be the length of mirror? You want to see his full image, so this will go here and it will reflect. He can see his feet. He want to see his hairs also. So what will happen? This will come here and it will reflect into his eyes. Okay. So now from here to here, how much height is there? 180 centimeter. So to see 1 centimeter full image, what should be the height of mirror? That is 180 divided by 2. So that is 90 centimeter. Above the eyes there is 20 centimeter. So to see the 20 centimeter of length, what should be the mirror required? Mirror required is 10 centimeter. So 20 by 2. So 10 centimeter. Total mirror required is, here it is 10, here it is 90. Again total height of mirror is what? Or length of mirror is going to be 90 plus 10. So that is 100 centimeter only. So length of mirror will not change even if you in the question if they change anything. So length of mirror is going to be half of the total height only. But what changes here is the height above which you have to fix it. It is not going to be 100 now. It is going to be 90 only. So height is going to be 90 only. Okay. So 90 centimeter. So this is what the length of mirror required is 100 centimeter. Where you have to fix? You have to fix 90 centimeter above the ground level. Okay. So similarly, suppose you are having a mirror. Suppose there is a mirror. Okay. So in front of that mirror at 1 meter distance, one boy is standing here. Okay. So whose height is again 1 meter. Behind that there is one more person standing whose height is going to be 2 meter. This person want to see the full image of this ball. Then how much mirror is required, or what should be the length of mirror, or where to fix the mirror? That is what the question. So how we can calculate? He want to see not his full image, he want to see full image of this ball. So what will happen? He want to see his feet also, so he can see his feet. Okay. He want to see his head also. So what will happen? This is what going to be here. Okay. So where image will form? Image will form somewhere here. This is what his feet, and this is what his head. Okay. So here is the person. Okay. means person's height. Now, so what you have to calculate? You have to calculate this x. If this is x, I will take this as y and this as z. You have to calculate this length of this mirror. Only this is a mirror which is useful. This and this one is going to be waste. So we have to calculate the x. For that, again we have to consider the mirrors. Similar triangles. So for that you consider this triangle. This is what one triangle, and you consider this total triangle. So these two are similar because this angle is same. This is 90 degree. Then so remaining angles are also going to be same. So right, if this is 1 meter and this is 1 meter, this is also going to be 1 meter because this is the image of boy. So boy is at 1 meter. So this is also going to 1 meter, not 2 meter, because it is, again I am telling, image of boy, not image of that person. Okay. So now ratio of sides, y by 1 is equals to, so total 2 by this divided by this, total is what, 1 meter, 1 meter, 1 meter, 3. So you got y equals to 2 by 3. Similarly, you can calculate here. This is one triangle and this total is one triangle. Okay. Here now this is what, 2, because 1 plus 1 2. Here it is again 1 meter. Z divided by 2. Z by 2 is equals to, so is equals to what? This is what, if this height is 1 meter, this is also going to 1 meter. 1 divided by 3. So 1 by 3. So Z is equals to what? Z is equals to 2 by 3. So we want x. So x plus y plus z. X plus y plus z. Total is equals to what? Total is equals to 2. So I will write 2 meters. So x plus y is 2 by 3 plus z is also 2 by 3 equals to 2. So x equals to 2 minus 4 by 3. So that is what, 6 minus 4 by 3. Again it is going to be 2 by 3. So your x is going to be 2 by 3. So length of mirror required is 2 by 3 meter. Or at what height you have to fix? You have to fix at a height y. What is y? Y is also 2 by 3 meter. Okay. So this is how we can calculate the length of mirror or height above which we have to fix the mirror. Okay. As we are discussing plane mesh, if I take one more point, if suppose mirror is the here, we already discussed this one. If the object is going to be here, if this is the object, so where image will form? Image will form somewhere here. Okay. So you have to join here. You have to take this mirror as perpendicular bisector. So what will happen? So this will reflect here. So where image will come? Image will form here. So similarly this will reflect in this manner. Okay. So where image will form? Image will form here. This is what your image. But a person standing here, he will not see his image because he is not in the field of view. This is what field of view. Any person comes here, he can see the image of this object, but this person cannot see the image. So based on this, if we want to know some problems, suppose a mirror is here, say it is 1 meter, length of mirror is 1 meter, and it is also there at a height of 1 meter above the ground level. Now at some distance, say 1 meter, or you can say at 2 meter, at 2 meter a person is, one object is there. Okay. So where its image will form somewhere here. Okay. So similarly, so image will form somewhere here. Will this person able to see image? He will not see his image. But where, if this person comes here, he can see the image. At 1 meter or 2 meter distance, one path is there. You can take, there is one path. Okay. So now if a person is moving in this direction, they will ask, after moving how much distance this person can see the image, or they may ask how much distance he can able to see the image. Getting the point? After still here he will not see the image. Take this as x. Till x distance this person will not see the image because he is not coming under the field of view. Now when he reaches the x, after traveling the x distance, when he comes in field of view, he can able to see the image of object. So we have to calculate x, or they may ask you to calculate this also, for how much distance he will able to see the image. Okay, so if you take total distance as d, so how we can calculate? Again we can use the similar triangle concept here. So one is, this is what, one triangle. Okay, so take another triangle, this triangle. So what you can take, if this is 2 meter, this is also going to be 2 meter. Take ratio of sides, 1 meter divided by 2. 1 by 2 is equals to x divided by 6. X divided by 6. So x is equals to what? X is equals to 3. X is equals to 3. Okay. That means what? After traveling 3 meter, he can start seeing the image. Now if you want to calculate this distance, what is this distance? This distance is d minus x. Total is d, this is x, so d minus x. For that you have to consider this triangle, this one triangle, and this total triangle. Okay. So for this triangle, what is the ratio of sides? This 1 meter, this 1 meter. 2 meter divided by 2. So 2 divided by 2 is equals to, this is what? D. This total is what? 6. So d divided by 6. So d is equals to what? 6. So you followed the total distance also. What you wanted? You wanted d minus 6. So d minus x is equals to 6 minus 3, that is 3 meter. Okay. So first question is, after how much distance he will able to see the image? After 3 meter. How long or how much distance he can able to see the image continuously? So d minus x, that is 3 meter. Okay. So similarly you can frame many questions yourself, or you go through some books, you can solve few problems. Again we will discuss about the plane mirrors in the next lecture.